Okay, in this video we're going to be talking about complex numbers. So we have these things called imaginary units. So I is the complex number whose square is -1. So if we square it, we get -1. And I equals the square root of -1. So we normally talk about how we can't have square roots under the radicals. In these situations, to get the negative out of the square root, we are going to put i's in because they're imaginary now. So if I'm trying to get rid of that negative, I can put an I out here, and it gets rid of it. And then sometimes we can simplify what's underneath this radical. So in this one, we want to get rid of the negative, so I'm going to put the I on the outside, and then we're going to go ahead and break this 18. So we can do 9 and 2, 3 and 3, and then I'm going to put them in this thing called radical jail. So 3, there's 2 3s and a 2. So for radical jail, you circle the pair. One can escape jail, but one dies in the process. So now I have a 3i on the outside and a square root of 2 because the 2 is left on the inside. Okay, so to get rid of that negative, we're going to do the I. This breaks down. We could do 4 and 3 and 2 and 2. So I have I square root of 2 times 3. We circle the pair. One escapes and one dies. So I have 2i square root of 3. Square root of 25 is just 5. So first off, let's get rid of that negative. Now we can take the square root of 25. So we should get 5i. Okay. Imaginary numbers, any number of the form bi, so an I attached to it, where a and b are real numbers, so like 1, 2, 3, 4, 5, 6, and so on and so forth. Imaginary numbers and real numbers together make up a set of complex numbers. So imaginary number is just a number that's attached to I. Complex numbers is when it's an equation like this, where we can have a number added to an imaginary. If we were graphing these would be my real numbers, and these would be my imaginary. Okay, so your x-axis is your real, and then your y-axis is your imaginary. So if I was doing -3, 4i, I would go left 3 for the -3, and then up 4 for the 4i. So then my point would sit right there. Okay, if there is a plus sign in the middle and I distribute this, it's not going to change anything. So I'm going to go ahead and write this without my parentheses. And then I'm going to combine my like terms. So 4 minus 4, they cancel. -3 plus 3, they also cancel. For my answer for this one is actually 0. This one, I got to distribute this negative because it is going to change something. So -1 times -3 is a +3. -1 times a positive I is a negative I. So 7 plus 3 is 10. -2 minus 1i is -3i. Okay, this plus sign, if I distribute, it's not going to change anything, so I'm going to go ahead and drop all of those parentheses. -3 plus 3 cancels. 9i plus 9i gets me 18i. Okay, this one, there isn't a plus sign or minus sign in here, so what we need to do is distribute it. So I'm going to get 3i times -5. And then plus 3i times 2i. So we got -15i. 3 times 2 is 6. I times I is I squared. But I said whenever we had an I squared, that represents -1. So I'm going to take out that I squared and put a -1 in. 6 times -1 is -6. Okay, 7 times 3 gets me 21. I times I gets me I squared. But I squared represents -1, so I'm going to change it to a -1. 21 times -1 is -21. Okay, this one, we have 2 terms in each, so I have 2 binomials, so I'm going to have to FOIL it this time. So if I do my first, I got 4 times negative 1, which is negative 4. My outside, so 4 times negative 2i. So 4 times negative 2 is negative 8, and we attach the I. I is inside, so we're doing 3i times negative 1. So 3 times negative 1 is negative 3, and we attach the I with it. And L stands for last, so 3i times negative 2i. So 3 times negative 2 is negative 6. I times I is I squared. I squared should change to negative 1, and we have like terms we can combine. So I have negative 11i. I need to change that I squared to a negative 1. So I get a plus 6 when I multiply them, and then we can combine these like terms to get 2. So my first, negative 6 times negative 6 is 36. My outside, negative 6 times negative I is a positive 6i. My inside, I times negative 6 is negative 6i. And my last I times negative I is negative I squared. If we combine these, they cancel, so I have 36 plus negative, that I squared changes to a negative 1. So 2 negatives will then make that a positive. 36 plus 1 is then 37. Okay, so when we're doing these ones with a number in the bottom of a quotient here, we're going to do this thing called the conjugate. The conjugate is whenever we take the opposite of, in this case, the bottom. Okay, so we're going to do the opposite of it. So the opposite of positive 3 is negative 3. So I'm going to multiply my top and bottom by negative 3. The reason that we're doing this is because I don't want an I in the bottom. I can't have any imaginaries in the bottom. So this will be the process of getting rid of the I in the bottom. When you multiply the top, you need to make sure you multiply everything on the top. So let's put those in parentheses. So I got to distribute. 9 times negative 3 is negative 27i. And then we got negative 3 times 12, which is negative 36. I times I squared. On the bottom, 3 times negative 3 is negative 9. I times I is I squared. I'm going to replace all my I squareds with that negative 1. So now the I is gone on the bottom. So I got negative 27, oops, that's supposed to have an I plus 36 over 9. We're going to break it. So negative 27i over 9 plus 36 over 9. Negative 27 divided by 3 is negative, or divided by 9 is negative 3. 36 divided by 9 is 4. Okay, so this time we got a positive 6, so we multiply that entire top by negative 6i, so we can get rid of the 6, so we can get rid of the I on the bottom. So if we distribute, we get negative 24i plus 6i squared over 6 times negative 6 is negative 36. I times I is I squared. Let's change those I squareds to minus signs, or to negative ones. So then I get negative 24i minus 6 over positive 36. We break it so that they both have the bottoms of 36. So negative 24i over 36 minus 6 over 36. We can divide this first set by 12, so we get negative 2 over 3i minus, divide both of them by 6, 1 over 6. Okay, if we're just trying to get rid of the I, this conjugate that we're going to multiply by is 1 plus 4i. So the thing that's attached to the I is what you're doing the opposite of. Remember, we multiply it by everything on the top. So in this situation, because we have two binomials, we're going to have to factor it. So if I'm doing the top, I have first, so 2 times 1 is 2. Outside, oops, is 2 times 4i, so I get 8i. Inside I have 3i times 1, so 3i. And my last 3i times 4i is 12i squared. On the bottom, first, 1 times 1 is 1. Outside, 1 times 4i is 4i. Inside, negative 4i times 1 is negative 4i. And my last, negative 4i times positive 4i is negative 16i squared. We got to change all of our I squareds to negative 1s and combine all like terms. So on the top I have 2 plus 11i plus 12i squared changes to negative 1. 1. These cancel on the bottom. Negative 16i squared changes to that negative 1. So all of my i's on the bottom disappeared, which is what we wanted. So 2 plus 11i minus 12 over 1 plus 16. So we can combine like terms again. So 2 minus 12 on top is negative 10. 1 plus 16 is 17. So let's go ahead and break it. So my answer then is negative 10 over 17 plus 11i over 17. Okay, so caring about getting rid of just the I, we do it by a minus 4i this time. And we're going to have to FOIL. So on top, first, we have 5 times 3, which is 15. Outside, 5 times negative 4 is negative 20. We attach the I. Inside, negative 2i times 3 is negative 6i. And my last, negative 2i times negative 4i, we get positive 8i squared. Let's do the bottom first. 3 times 3 is 9. Outside, 3 times negative 4i is negative 12i. Inside, 4i times 3 is positive 12i. And then my last, 4i times negative 4i is negative 16i squared. Let's get rid of that parenthesis. I squared. Combined like terms, change your I squareds to negative 1s. So 15 minus 26i plus 8 times negative 1. 9, my i's cancel, minus 16 times negative 1. 15 minus 26i minus 8 all over 9 plus 16. Combine like terms on the top and the bottom. So we got 15 minus 8, so we got 7 minus 26. I over 9 plus 16 is 25, and then we break it. So 7 over 25 minus 26i over 25. Getting rid of the 7 on the bottom, we're going to multiply by 8 minus 7i on top and bottom. So if we do our first, we get 64. Outside, minus 56i. Inside, minus 56i. And then my last, a positive 49i squared. Bottom, 8 times 8, we got 64. Outside, 8 times 7 is negative 56i. Inside, positive 56i. And then my last, 7 times negative 7, we got negative 49. I times I is I squared. We're going to combine like terms, change our I squareds to negative 1s. So negative 102i plus 49 times negative 1. 64, they cancel. Minus 49 times negative 1. 64 minus 102i minus 49 over 64 plus 49. 64 minus 49. We got 15 minus 102i over 64 plus 49. 113. We break it, so 15 over 113 minus 102i over 113. Yeah, this was supposed to be 112 right here. 56 plus 56 is 112. Boop. Okay. Alright, if I were solving this, I'm going to subtract 32. So I got 2x equals negative 32. Divide everything by 2, so negative 16. And then square root both sides. So this is going to look similar to what we have been working with, where there's a negative. But I want this simplified. So let's go ahead and get that negative out of there. And let's simplify that 16. Okay, and remember whenever we're solving these, they should have two different answers. So our plus or minus. Okay, square root of 16 is 4. So my answer is plus or minus 4i or I4. Solving this, let's go ahead and subtract 20. Divide by 5, so x squared equals negative 4. Square root both sides, so it becomes a plus or minus. Get rid of that negative underneath the square root. Square root of 4 is 2. Okay, this one we're going to have to factor because there's 2 terms. So let's go ahead and send this 2 back. And think what multiplies to get me 10, adds to get me negative 3. We could do 5 and 2, but for it to be a positive 10, that's not going to work. I can't think of anything that's going to add to give me negative 3, so I need to go back to square 1 and use the quadratic formula. So we got x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So a is 2, b is negative 3, and c is 5. So x equals negative b. Well, if it's already negative, I plug it in, it's going to be positive. B squared minus 4 times that a times that c all over 2 times that a. I simplify underneath my radical first. Negative 3 squared is 9. 4 times 2 is 8. 8 times 5 is 40, so we got minus 40. 2 times 2 is 4. X equals 3 plus or minus 9. Minus 40 is negative 31. Let's go ahead and get that negative out of the square root, so it becomes x equals 3 plus or minus I over 31. Square root of 31 over 4. I can't break the square root of 31 down anymore, so what I'm going to do is I'm going to move it so that I just have the 4 underneath both of them. So 3 over 4 plus or minus I square root of 34 over 4. Okay, so if I send my 3 back, let's see if it works this time. So x squared minus x plus 9. So 3 times 3 gets me 9, 9 times 1 gets me 9. There's nothing else, so I'm going to have to use the quadratic formula again. So this is my a, my b is negative 1, and my c is 3. So I got x equals negative b. Well, if it's already negative, then I have to put it in as positive, plus or minus my b squared minus 4, times a times c all over 2 times a. So x equals 1 plus or minus 1. 4 times 3 is 12. 12 times 3 is 36. 2 times 3 on the bottom is 6. X is equal to 1 plus or minus the square root of negative 35 over 6. Let's get that negative out of there. So it's I square root of 35 over 6. If I broke 35, it's 7 and 5, but I can't break it down any further, so my radical jail is not going to change. So we're just going to write it 1 over 6 plus or minus I square root of 35 over 6.